Hello, assalamu alaikum dear students. You are watching my channel Shahsras Physics class. I welcome you all. Before I start today's lecture is very interesting. In fact, every physics topic is interesting, But before I start today's topic, I have a simple question for you. The question is, I have already told you a lot about that refractive index. The question is related to the refractive index. Tell me what is the SI unit of refractive index. Comment में ज़रूर लिखना. If you know the answer, you can comment. Okay, now today's lecture is points to remember. Since we are dealing with the refraction, so there are certain points that you have to keep in mind. And here on the board, you can see there are two important points that you have to remember. What is the first point? You can clearly see when light travels from rarer medium to a denser medium, it bends towards the normal. This is very important point, beta. It is always asked in your examination. So see, suppose incident ray is AO, it makes an angle SI, sine of angle of incidence, and it will go into the denser medium like water. You can check sine I is greater than the sine R. Okay, always remember, my dear, when light travels from rarer medium, I have already told you what is rarer medium. Rarer medium mein velocity of light is faster, while as in denser medium velocity of light is very slow. It slows down the velocity of the light when light travels from when light enters into the denser medium. Denser medium, it has a refractive index, it has the ability to bend the light. Already explained that. Optically denser medium, or you can say optically rarer medium. Right, my dear? So rarer medium is that medium in which the velocity of the light is faster. Okay. So always what the 2 point is that you have to remember now. When light travels from rarer medium to denser medium, it bends towards the normal. और एक पॉइंट मैंने यहाँ पे ऐड किया है, when light travels from rarer medium to denser medium, at that time sine of incidence is greater than the sine of refraction. You can easily see that. This is the first point. So whenever light travels from rarer to denser, it will go towards the normal. It will bend towards the normal. And इसका उल्टा. Second point, when light travels from denser medium to rarer medium, it bends away from the normal. At that time, इसका opposite लिखो, sine I is less than the sine R. Here is the diagram. So these are the 2 points that you have to remember, beta, because after that we are going to discuss a very important topic, that is refractive index through a glass slab. वहाँ पे आपको ये सीखना है, तो इसलिए मैंने इसको पहले से ही आपको important points में बताया ताकि आप इसको अच्छे से remember कर सको. ठीक है बेटा? तो 2 points is clear. You can have the screenshot of it. Okay, my dear, it is clear. So is this clear? Now I'm going to rub it. I hope कि आपने इसका स्क्रीनशॉट उठाया होगा, या आप कॉपी और पेन, you can note it down each and every point because this is very important. Okay. Now the one more point that you have to remember is, what is the condition of no refraction? ये भी क्वेश्चन आ सकता है, little bit tidbits है related to the refraction of the light. Little bit you have to remember this. So the second thing what you have to remember is the conditions. What conditions are necessary when you say that there is no refraction? Conditions for no refraction. The third point that you have to remember is conditions for no refraction. Okay, so my dear, again you have to remember the 2 points. There are 2 conditions where you can say that there is no refraction, where you can say there is no refraction. One point I will write here, suppose this is xy is the interface. If the incident ray is normal to the plane, beta, what will be the angle with the normal? It is 90 degree and sine I will be 0, and it will pass into the another medium. Say for example this is rarer medium and this is denser medium, but the incident light this time it is normal to the plane. You can see this is normal. What does it mean? Normal means angle is 90 degree, so sine I will be here 0 and sine R will be also 0, so it will go along the straight line. So this is the condition where you can say there is no refraction. Why you can say there is no refraction? So this is the first condition जहाँ पे आप कह सकते हो कि भाई यहाँ पे refraction नहीं हो सकती है. कब? When the incident ray is normal to the interface. When, शाबाश, when the incident ray is normal to the plane या टू द मीडियम. आप लिख सकते हो जिस मीडियम में इसको जाना है उसका जो प्लेन है ये वाला इंटरफेस अगर ये नॉर्मल है तो एंगल साइन ऑफ इंसिडेंस इज 0, साइन ऑफ आर दैट इज रिफ्रैक्शन इट इज आल्सो 0, सो इट कैनॉट इट गेट्स अनडिविएटेड. रिफ्रैक्शन में क्या होता है बेटा? लाइट वहां से आती है रियरर मीडियम से और जाती है डेंसर मीडियम में. देयर इज बेंडिंग ऑफ लाइट. Here no bending of light takes place because the incident ray is normal to the plane. It makes an angle 90 with the normal, that is why it is 0, and here is also 0. So this is the case when the incident ray is normal to the plane, normal to the medium. Better I will say it is normal to the medium, normal to the denser medium, whatever you can say. So this is what we called it is the condition where you can say there is no refraction. This is one point. Second point, very easy, very quickly I will write here. Again I will take suppose xy. तो ये xy जो इंटरफेस है, अब ये हमारे पास दो मीडियम है. Say for example it is medium first and this is medium second, right? अब ये मीडियम, अब देयर आर टू मीडियास, लाइट कमिंग फ्रॉम फर्स्ट मीडियम एंड देन गोज इनटू द सेकंड मीडियम. सो रिफ्रैक्शन तो होनी है बिल्कुल, लेकिन ऐसी कौन सी कंडीशन है जहां पे रिफ्रैक्शन नहीं होगी? एक कंडीशन और है सर, अगर रिफ्रैक्टिव इंडेक्स ऑफ फर्स्ट मीडियम इज सेम टू दैट ऑफ द सेकंड मीडियम. Okay my dear, this is optically denser, sorry, it is refractive index, it is refractive index. If the refractive index of both the media are same, say for example n1 is 1, इसका भी n2 1 है, तो refractive index of medium first is 1, refractive index of what? शाबाश, second medium is again 1. तो when the refractive indices are same for the both the medias, at that time it goes undeviated. Are you getting my point my dear? Okay dear, so what is the second point? So if the refractive index of medium 1 is equal to the refractive index of medium second medium, so if the refractive index is now same for the both medias, this is again the second condition where you can say there is no refraction. तो second point हम क्या लिखेंगे बेटा? जल्दी से हम आपको बताएंगे, जल्दी से. Second point is, शाबाश, आप खुद ही बता सकते हैं, if the refractive, शाबाश, if the refractive index of both the media are same. Good. So here अगर आपको अब डायग्रामेटिकली अगर आपको इसको दिखाना है तो आप ऐसे दिखा सकते हैं लाइक दिस. तो इससे क्या पता चलता है आपको बेटा? अब सर एग्जाम्पल से हमें समझाएं. I have already told you yesterday in my previous lecture that refractive index of vacuum is exactly 1 and refractive index of air is approximately equal to 1. So when light travels from vacuum to air, so there will be no refraction. The refraction is, beta, negligible. So this you can write the example here. You can write the example. Angle of incidence is equal to the angle of, so यहाँ पे हम लिख सकते हैं sin I will be equal to sin R. अगर बेटा इनका रेशियो निकालेंगे sin I by sin R, तो क्या निकलेगा बेटा? exactly 1. समझ आया बेटा? तो what are the two different conditions where you can say there is no refraction? सर अभी हमने कहा कि when the incident ray is normal to the plane or medium, so at that time there is no refraction. Second point, sir, if the refractive index of both the media are same, at that time no refraction takes place. Okay, this is clear. This is clear. So this was the second point. So point is to remember. Once again, जो क्वेश्चन मैंने पहले बोला है, what is the SI unit of refractive index, आप वो कमेंट में ज़रूर लिखना. ठीक है बेटा, मुझे आई होप कि आपको वो आएगा, लेकिन फिर भी आपको कमेंट में ज़रूर लिखना है. ओके ओके ओके. नाउ माय डियर, आई थिंक अभी हमारा एक क्वेश्चन इसमें रहता है. आफ्टर दैट हम स्फेरिकल लेंसेज पे आते हैं. तो आज जो नेक्स्ट पार्ट जो हमारा आज का है वो है रिफ्रैक्शन थ्रू ए ग्लास स्लैब. वेरी इंपॉर्टेंट. तो जल्दी से हम आपको बताएंगे. सो क्वेश्चन आई विल राइट हियर, रिफ्रैक्शन थ्रू अ glass slab. In fact, it's a rectangular glass slab. So I will write here first of all, diagram is very important. Your question is half done when your diagram is okay. कहते हैं ना, diagram is the worth, diagram is important when you compare the diagram with 100 words. So 100 words is equal to the simple diagram, my dear. Is it clear to you? So what is our topic today? Refraction through a glass slab. We have done so many questions related to the refraction. Now it will become very easy for you. You can very easily understand refraction through a glass slab. So simply I am going to make a very lucid and very clear diagram here. गिलास स्लैब, फर्स्ट ऑफ ऑल गिलास स्लैब की शेप क्या होती है? इट इज़ अ रेक्टेंगुलर शेप. जब आप स्कूल जाओगे ना बेटा, अगर आप प्रैक्टिकल्स वहाँ पे करोगे तो ये प्रैक्टिकल वहाँ पे आपको करना ही करना है. आप वहाँ पे देखोगे गिलास स्लैब, प्रिज्म एटसेट्रा. यू विल कम टू नो प्रैक्टिकल में, फिर आपको ज़्यादा अंडरस्टैंड होगा कि जो सर ने पढ़ाया वही आप डेमोन्स्ट्रेट भी करते हो, उससे आपको बहुत ईजी होगा. तो चलते हैं बेटा जल्दी से. I will take a glass slab. So here it is, glass slab. It is rectangular in shape. Suppose I will write it P Q R S. P Q R S is a rectangular slab. You can see, my dear, there are two interfaces. One is PQ. So the first refraction takes place at what? Exactly on PQ. See, अब ये गिलास जो है, it is denser, right sir? It is denser. But light को कहाँ से आना है भाई? सर, air से. And you know, air is rarer. Air is rarer medium. Air का अपना refractive index होगा, तो let us we take it as Na. तो लाइट को कहाँ जाना है भाई? गिलास में. तो इसको मान लीजिएगा कि it is Ng. It is Ng. So simple. तो चलते हैं बेटा. Suppose AO is the incident ray. AO is the incident ray. I will write it like this. AO is incident on what surface, Shabash? On PQ. So आपको नहीं लगता this is the first refraction to take place? So where it takes place? At PQ. Okay. And as you know, glass is denser, so it will bend like this. Okay. what I have to draw? Normal. So what angle? Yes, it is sine of incidence according to Snell's law, right my dear? And what is this? It is sine r. इसको थोड़ा बहुत ये थोड़ा कंजेस्टेड स्पेस यहाँ पे आप खुद ही अंडरस्टैंड करना, ठीक है? It is sine r. तो light is coming from the rarer medium and it enters into the denser medium, so it will bend towards the normal. पहले ही पॉइंट मैंने वहां पे लिखा, that is why मुझे पहले वो समझाना था, तो यहां पे easy होगा. After that it will come out from the glass like this. So this ray is coming from what to what? Denser to rarer. It will go away from the normal. So I will write here like this here. ठीक है? तो यहां पे again we have to make, this is sin r2, इसको हम लिखेंगे sin r1 because two refractive angles बनेंगे ना यहाँ पे, and this is sin of E. What is E? It is emergent ray, and emergent ray will make angle of emergence, sin E, इसीलिए मैंने लिखा. अब आराम से देखिए आप. Now we have to calculate this. देखिए, since it is a rectangle, PQ is parallel to the RS. If you produce this line like this, yes. So emergent ray is parallel to the incident ray when produced. Shabash. Since this is parallel, this and this is parallel, and now this incident ray is parallel to the emergent ray, and there is a distance. Let us denote it by x, and this is called as lateral shift. ये कभी आ सकता है एग्जाम में, lateral shift. तो डायग्राम में आपको इतना ही लिखना है. तो we will come up with the derivation, and that derivation inshallah we will do tomorrow. It is all for today, and I hope that you have enjoyed the lecture and you have watched my video till end. If you really like my video, do subscribe my channel and don't forget to comment, because I already told you comment is our confidence, because your comment is our success. Thank you. May Allah bless you and keep always learning. Thank you. Have a nice day.